Okay, hello and welcome to the solution of ISI M.MAth 2024 question based on linear algebra. The first question they have asked us that suppose V be a finite dimensional real vector space and T is such that V to V is a linear transformation satisfying the condition of rank of T square equal to rank of T. Then we need to prove that kernel of T equal to kernel of T square and also card of T intersection TV equal to the zero vector. Zero vector is the only intersecting vector between card T and TV means empty. Now, so let us start the solution. So, thing which is given to us is rank of T equal to rank of T square. First, let's talk about T square. What is T square? The T says that V to V is a linear transformation, where V is a definitely finite dimensional vector space. You need to observe that. Finite dimensional vector space. So, T square is also a linear transformation from V to V, right? Now, what is meant by rank of T? Rank of T is the dimension of empty. And what is rank of T square? This is the dimension of T square. Now, kernel of dimension as V is a finite dimensional vector space. So, by using rank nullity theorem, I can write dimension of part T equal to plus dimension of empty. This is equal to dimension of V and dimension of part T square plus dimension of T square. This is equal to dimension of V as well, right? So from these two equations, I actually can equate them as both of them equal to the dimension of V and dimension of empty and dimension of empty square is same. So from this, I actually can say that dimension of part T equal to dimension of part T square, right? You also need to observe that card T and card T square are two subspaces of V having the same dimension. Now let us choose a vector alpha belongs to card T. Now by definition of kernel of a linear transformation, I can write T of alpha, this is equal to the zero vector. Now let us check what is the value of T square alpha. Now T square alpha means T of T alpha. Now T of alpha is equal to 0. Let us write 0 in place of T alpha. So that gives you T of 0. And as T is a linear transformation, that maps the 0 vector to the 0 vector. So I can say that T square of alpha, that gives us this 0 vector. Now T square alpha gives 0 vector implies alpha belongs to kernel of T square. Observe that I choose this alpha from card T and I have proved that alpha belongs to card T square. So I can write kernel of T is a subspace of kernel T square having the same dimension of card T equal to dimension of card T square. We know that two subspaces of V having the same dimension are same. So from this I can say that kernel of T equal to kernel of T square. So this is our first proof. Now we'll move to the second question. While the second question they have asked us to prove card T intersection TV is equal to 0 vector. 0 is the only intersecting vector between card T and empty. So let us start. Let us start by choosing a vector alpha belongs to card T intersection empty. So as alpha is the intersecting vector between these two subspaces, so I can write alpha belongs to card T. Now alpha belongs to card T implies T of alpha is equal to the 0 vector, and also observe that alpha belongs to empty. This implies alpha belongs to empty. This implies T of alpha, alpha equal to, just a second, I can write alpha equal to T of some beta. Well, beta belongs to V. Now let us take the value of t squared beta. T squared beta. So t squared beta is nothing but t of t beta. So that is equal to t of. Now I am writing alpha in place of t beta. Now what is the value of t alpha? T alpha is the 0 value. From this I can say t squared beta is equal to 0. Now t squared beta 0 implies beta belongs to kernel of t squared. But I already have proved kernel of t is nothing but the kernel of t squared. So in place of kernel of t squared, I can write kernel of t. So beta belongs to ker t. Now beta ker t belongs to ker t implies t of beta equal to 0. Now what is the value of t of beta? Just observe that. T of beta is nothing but the alpha. So I can write alpha equal to 0. So the only intersecting vector between ker t and mt becomes this 0. Therefore, ker t intersection t mt, they have written mt as t of v is equal to the 0. That's all about the question. Thank you.